Hello everyone. Today we will see the Leetcode problem number 1339, which is maximum product of splitted binary tree. Let's see what the question says. Given the root of the binary tree, split the binary tree into two subtrees by removing one edge. Okay, we have to split that binary tree into two subtrees by removing any one of the edge. Now such that the product of the sums of the trees is maximized. Okay, if we are dividing by removing this edge, so this sum multiplied by this sum, so this total multiplication we have to maximize it. Okay, now return the maximum product of the sums of the two subtrees. Since the answers may be too large, so return it in modulo 10 to the power 9 plus 7. Note that you need to maximize the answer before taking the mod and not after taking it. So this should be a note which is provided. Okay, so let's take this example. Okay. We will just take this example. Okay, now in this example what is given here, there is a 1 2 4 5 3 and 6. So this if we are dividing this with if we are removing this edge, so we will get this and also this. Okay, their sum will be 11 and sum will be 10. Now how we will approach that this edge we have to delete only. So we have to figure out that which edge to delete and how much sum we will get by deleting that edge. So how we will do it, that when we are currently at this edge, okay, this root node. Okay, root node means at the 1. Okay, at the 1, when we are at this 1, so we have to get the whole right side sum, means 3 and 6 sum, and with this also, so 3 plus 6 plus 1. Okay, I will just tell you that how our approach will be. When we have the, I will draw it. Okay, I will draw it below this image. Okay, just a second. 4 5, okay, and 6 and 3. Okay, okay, now we have this tree, and now when we apply any DFS, okay, for this we just have to know the total sum of all the nodes. Okay, we will just find out the total sum of all the nodes by using DFS or BFS. We can use DFS or BFS, any of them, BFS also. Okay, and to find the total sum. Okay, now after finding the total sum, we just only have, okay, just think about it. If you have the total sum, so if you have the total sum and the sum when you want to delete this node, okay, so when you want to delete this node, what do you want? This sum and the total sum. So you will get you can now find out this sum. How? This sum will be the total minus of this sum. Okay, sum 1 sum 2. Okay, this is a sum 1, I will say. Okay, sum 1. Okay, this is a sum 2. So total minus of sum 2 sum 1 equal to total minus of sum 2. Okay, total minus of sum 2, which will be the sum 1. Okay, and if we have the sum 1, so we can find sum 2 by sum 2 is equal to total sum minus sum 1. Okay, so we only want the total sum and the sum 1 or sum 2. Okay, after that we can find out that for dividing this age, how much answer, how much score we will get. Okay, and we have to maximize this score. Okay, now how to maximize it? The answer will change each time if max of answer and the sum 1 into sum 2. Okay, sum 1 into sum 2, sum 1 into sum 2, sum 2. Okay, so in this way the answer will be changed each time. Okay, now if we take this node, this age. Okay, if we think about this age, this different age. Okay, sorry, this age is already there, and if we think about this age to cut. Okay, so we will need this sum or else this sum. Okay, and the total sum we have already, so we will get the sum 1, sum 1 or sum 2. Okay, we just have to know either sum 1 or either sum 2, and the total sum we already know. Okay, so after that the answer will be modified again. Okay, and now for the node, for the age this one, we only need to know this sum and this sum. Okay, this sum, either this sum or sum 1 or either sum 2. Okay, so now just think about it and get the approach. I will explain you apart from this by using the code only. Okay, so how we will apply this. Okay, so firstly we have the root. Okay, firstly we have the root is given to us, then the total sum we will count by using, we can use the DFS or BFS also, BFS, any of them. Okay, any of them we can use. Now I have pushed the root into the queue, then I will run until the queue becomes empty. Then every value of that queue dot front we will update in the total sum, then their left and right childs will be pushed into the queue, then pop out the queue dot root, means queue dot front. Okay, so in this way the BFS will return us the total sum. Okay, it will calculate the total sum in this way. Now what now how we will calculate our answer, which is that total multiplication of two sub trees. Okay, now we have to divide the subtree into two parts. Okay, now we have taken the answer means we have to find the maximize, so we can take as a int minimum also, it can also be validated. Okay, valid. Now sum is equal to DFS. So why this sum is equal to DFS we have taken? This function only returns just like this 1 2 and 4 is there. Okay, 1 2 and 4 is there. So this function, what this function will do, it only returns the sum of their child nodes. Okay, sum of their child nodes and the current sum. Okay, current sum of that current node. Okay, so it will return the 4, it will return the 2 to this node. Okay, after that if we have another variation like 3 and 8, sorry, 3 and 8, so it will return the 3, it will return 8. After that 11 will be there and it will return 11 plus 2 is equal to 13. 13 to, it will return the 13 to root node 1. It will return 4. Then finally in this place, in this line, it will return what? It will return 13 plus 13 from this side, 13 from left side, 4 and 1, 1 plus 4. Okay, this will be the return by this sum. But now we are modifying it because we have to know that if we have to remove this node, okay, if we have to remove this node, so we just want to know about the sum of this part. Okay, so this sum of this part will be written by the DFS function, which is 11 plus 2. Okay, sorry, 11 plus 2, yes. Okay, let's see this function, what the DFS is doing, that when we are okay, this is a base condition. If the current is equal to null, so it will return 0. Okay, and the sum what it actually does, that current value, it also adding the current value into it. Okay, and their childs and right child and left child, so whole their subtree is adding there. Okay, so we are getting the one subtree from this. So we are getting the one subtree from this two, so from this 3. Okay, from this 3 line we are getting the one subtree, and after that we are calculating our answer, we are modifying our answer if we are getting the more sum from this. Okay, so this sum is giving us a one subtree sum, and this function, this calculation is giving us a second subtree sum. So we are multiplying this and modifying our answer. So in this way our answer will get changed and we will return the okay. So in note it was given that you need to maximize the answer before taking the mod and not after taking it. So this is the in this sentence you have to focus that after taking the mod, the answer may be answer can be the small. Okay, so after taking after modifying the answer, after calculating the answer, you have to calculate it in the long. That's why. Okay, because it can be greater than the int, obviously, because it was mentioned it here, because it may be too large, return it modulo 10 to the power 9 plus 7. So that's why you have to use the long here, and after that the answer cannot be in the int, so that's why you have to place here mod. Okay, and that's the solution. If you are not able to get any of the concept for this question, so you can comment it below and I will be try to clear your doubts as early as possible and as much as possible. Thank you.